Hello and welcome back to my channel. Today in this video we are going to discuss Cambridge International AS and A-Level Mathematics P1, Pure Mathematics 1, 970913 from May-June 2021. So I have already solved the questions and we are going to discuss the solutions. So let's start with the question number 1. So here's the question. A curve with equation y equals fx is such that f dash x is given as 6x squared minus 8 over x squared. It is given that the curve passes through the point 2, 7. Find fx. So we know that whenever we have f dash x given and we need to find fx, we are going to do the integration. So that's what I have done here. So here this is the integration. Fx become integration of the things which is given as f dash x. And since it is 6x squared and 8 over x squared, so I transfer this x squared in the numerator, so it becomes x to the power minus 2. Now we know ax to the power n integration, and that's why it is x cubed upon 3, and we cancel it. It is 2x power minus 1, because minus 2 plus 1 is minus 1, and we divide by minus 1, and plus a constant of integration. So if we simplify, we get 2x cubed plus 8 over x plus a constant of integration. And we are going to put this value which is lying on the curve, that is 2, 7. So y means fx is 7, then at that time there is a x is given as 2, so we substitute it here. We get this as 16 plus 4 plus constant of integration c, and from here we can get the value of constant of integration, that is minus 30, and hence we get the equation of curve, that is 2x cubed plus 8 over x minus 30. That's our fx, for which f dash x is given as this. Here's the question number 2. The function f is defined by fx equals 1/3 of 2x minus 1 to the power 3 by 2 minus 2x, where x is in between half and a. It is given that f is a decreasing function. Find the maximum possible value of constant a. So since it is given that f is decreasing function, it means f dash x is less than 0. So we have fx, we get f dash x. It is 1 by 3 as it is. We take this power down, 3 by 2 here, and then we subtract 1 from the power, and then by chain rule we'll multiply by the differentiation of this bracket, that is of course going to be 2. So we multiply by 2 here and minus 2, because the integration or differentiation of minus 2x is minus 2. And when we simplify after cancelling on all the values, so we get 2x minus 1 to the power half minus 2. And here we are going to calculate this, because f dash x is less than 0 for decreasing function, so this becomes the power half is root, minus 2 is less than 0, so I transfer this minus 2 here, it becomes 2x minus 1 root is less than 2, and after taking the square both the side, we get 2x minus 1 is less than 4, from where we get 2x is less than 5, and that's what x is going to be less than 5 by 2. So since x was in between 1 by 2 and a, and x is less than 5 by 2, so the maximum possible value of a can be 5 by 2. That's how we get the value for the domain of a function with the conditions given. Here's the question number 3. A line with equation y equals mx minus 6 is a tangent to the curve with equation this. Find the possible values of the constant m, the corresponding coordinates of the points at which the line touches the curve. So since they are finding they are going to calculate for point of intersection, or the line touches the curve, we are going to equate our equations. So equation of curve x squared minus 4x plus 3 is equals to the equation of line. We do it because they are going to we are finding the intersection point. So at intersection point the curve has to get the same value. So from here we transfer this mx minus 6 to the another side, so that we get a quadratic equation in x, and we can simplify a little bit more, so it becomes x squared minus 4 plus mx plus 9 equals 0. Now since they have given that line touches the curve, it means the line has to be tangent, or we can say there is, for this quadratic equation we have to get only one solution, and for one solution we have b square minus 4ac as 0. From here we get 4 plus m, it's minus 4 times 4 plus m, but square will not make any difference, so square will not be different, like we can take the only positive value, so it is 4 plus m whole square minus 4a means 1 and c is 9 equals 0. We simplify this. It's better not to open the bracket. We can simply transfer this to the other side. We get plus 36, and after taking the square root for removing the square, we get 4 plus m as plus minus 6. So once we take plus, so we get 4 plus m equals 6, which gives us m equals 2, and for with minus 4 plus m equals minus 6, which gives m as minus 12. And since they have asked for the corresponding coordinates of the point at which the line touches the curve, so once we get the constant value m, we are going to find the coordinates, and for the coordinates we only need to solve the equation. With m equals 2 we get this, because our equation was x square minus 4 plus mx plus 9, so it becomes x square minus 6 plus 9 equals 0, which gives x minus 3 whole square equals 0, which means x equals 3. And from here, once x equals 3, we can substitute either in the curve or in the line, so it is y equals mx minus 6 become y equals 2 times 3 minus 6, and which is 0. So one coordinates, the point of one coordinates of one point is 3 comma 0. From here I'll use the different color, 3 comma 0 for the first one when m was 2, and similarly for m equals minus 10, we get x square minus 4 minus 10x plus 6, which will give us 6x square plus 6x plus 9 equals 0, which is x plus 3 whole square equals 0, means x equals minus 3. And we substitute this value in the y equals mx minus 6, and we get 24. So another point of intersection, or coordinates of another point is minus 3 comma 24. Here's the fourth question. Show that the equation tan x plus sin x over tan x minus sin x equals k, where k is a constant, may be expressed as 1 plus cos x upon 1 minus cos x equals k. So all we need to convert this tan left hand side of this equation into cos, so that we can get this. So we will start by changing tan x as by sin x upon cos x in the numerator as well as in the denominator. Now we can see plus sin x is there, minus sin x is there, equals k. We haven't touched it. Now from the numerator we can see sin is common, so after taking sin common we are left with 1 over cos x plus 1 in the numerator, and similarly in the denominator we are left with 1 over cos x minus 1 equals k. Sin x got cancelled, and here we take the just a second, it's plus not minus. So when we take the LCM, we got 1 plus cos x upon cos x and 1 minus cos x upon cos x. Cos x got cancelled, and we are left with 1 plus cos x upon 1 plus cos x upon 1 minus cos x equals k. That's how we had to actually express. So that's how we deal with the trigonometry equations. Next, B part, hence express cos x in terms of k. So since it is given that we are going to, it's a hence means we are going to use the result from the previous part. So previously we got 1 plus cos x upon 1 minus cos x equals k. So we simply cross multiply, we get this, and we collect cos one side, so it is cos x plus k times cos x, this left hand side, and the right hand side become k minus 1. So afterward we take cos x common, which gives us 1 plus k in another bracket, and here it is k minus 1. So we got cos x equals k minus 1 over k plus 1 by taking the cross multiplication here. So that's how we express cos x in terms of k here. And here's the C part, hence solve the equation this equals 4, and values of x has to lie between minus pi and pi. So since it is hence, we can understand that we are going to use the result from the previous part. So from A part and B part we have this left hand side as 1 plus cos x over 1 minus cos x, and here k value is 4, so it becomes this. And we from the second part, from the b part, we got cos x as k minus 1 over k plus 1. Here k is 4, so it is directly 3 by 5. So from here x become cos inverse of 3 by 5, and which is from the calculator we get 0.92729 and so on. And since we are dealing with the cos, so other angles we can deal in this range minus pi to pi. Of course, for the cos theta we get another angle as cos minus theta, so another angle would be minus x, that is minus of this, and next angle would be 2 pi minus this value, which is of course going to be beyond this limit of x. So our solutions would be only x equals 0.927 and minus 0.927. And here's the fifth question. The diagram shows a triangle ABC in which angle ABC is 90 degree. We can see it is 90 degree and AB is 4 centimeter. The sector ABD is part of circle with center A. Okay, this is the center. The area of sector is 10 centimeters square. So area of sector is given, means it's here this area of sector is 10 centimeters square. So it means and we need to find the angle BAD in radians. So we can mark this as theta. Let's say if this angle is theta, I will use this color. This angle is theta. So by the formula area of sector, we get this as half r square theta, and r here we can see is going to be 4 centimeter, and this is given as 10. This is the area of sector. It is given as 10 centimeter square. So we simplify here, and r square 4 square is 16 by 2 and then this 10 become 20 by cross multiplication, and we got theta as 20 by 16, that is 5 by 4, and hence we can say it is 1.25 radians. This calculation only can be done in the radian in this way, otherwise for the degree it would be a little bit different. And for the B part, I have copied the diagram here, and this angle we got as 1.25 radian. Find the perimeter of the shaded region. So shaded region, we can see this includes the arc length of BC and DC. So what we are going to do, first of all, we will calculate the arc dt, that is of course r theta, we know the formula, and it is 4 into 1.25, that is 5 centimeter. And for BC we have this angle as 1.25 and this side length is 4, so we are going to use tan. So tan 1.25 is BC, opposite upon adjacent is 4, so BC become 4 times tan 1.25, that is 12.038 till 3 decimal places. And for DC, we require DC length. So what we are going to do, we are going to calculate this total length, and for that we have used cos 1.25 for adjacent upon hypotenuse. So from here at AC become 4 over cos 1.25, which is 12.685, and hence DC would be this total length minus 4, because this AD is also a radius, that is going to be 4. So we got 8.685. And finally the perimeter would be this arc length, BC length and DC length. So it becomes 25.723, and till 3 significant figure we can write our answer as 25.7 centimeter. Here is the sixth question. Functions f and g are both defined for x belongs to real number. So it means it belongs, the domain is complete real number. Fx is given as x square minus 2x plus 5 and gx is given as x square plus 4x plus 13. A part, by first expressing each of fx and gx in the complete square form, express gx in the form of f of x plus p, where p and q are constant. So first of all, as it is given that we need to use the completing square method. So fx become, because since it is, we only look at the first two terms for the completing square. First thing has to be like x square coefficient has to be 1. So since it is given, so directly we can use x minus half of the coefficient of x whole square and minus square of that number, plus 5 is already there. So we got this as x minus 1 whole square plus 4. And similarly for gx, we got x plus 2 because it was x square plus 4, so x plus half of 4, so x plus 2 whole square minus 2 square plus 13 is already given. And we simplify, we get x square plus 2 whole square plus 9. Now since they have asked to express gx in form of this, so first of all we'll write gx again. Gx is x plus 2, and we know that in fx it is 1, x minus 1. So we can write this 2 as 3 minus 1. And this 4, there is a 4 in fx, and in the gx it is 9. So we can write 9 as 4 plus 5. Now we can collect the required term. Since we are going to write f of x plus something, so in order to use the fx, we have to make this as x, and it is minus 1, and there is a plus 4 of fx. What are the things extra? We can see it is minus 1 and 5, you can say. So x plus 3 minus 1 and plus 4, x plus 3 become f of x. It will become f of x because f of x is x minus 1, the input minus 1 plus 4. So it is input minus 1 plus 4, and plus 5 is as it is, we copy here. So finally we get gx as f of x plus 3 whole square. Sorry, it is not square here. I need to remove this. It is not square because this is the function. So this is going to be f of x plus 3 and plus 5 here. So that's how we express gx in the terms of in the form of f of x plus 3 plus 5. So we can also mention that p is 3 and q is 5. And here the describe fully the transformations. Describe fully the transformation which transform the graph y equals fx to the graph y equals gx. So from first part we have seen gx is f of x plus 3 plus 5. So it means we can see from the bracket, this is the x translation and this is the y translation. So we can say it is a translation by the vector minus 3, 5. So horizontally it is minus 3 and vertically it is 5. That's the transformation. Now here's the 7th question. Write down the first 4 terms of the expansion in the ascending power of x of a minus x to the power 6. Since the power is 6, so we by using the Pascal triangle, I have written the coefficient, that is 1, 6, 15, 20, 15, 6 and 1. We can also use NCR formulas, but it's fine if the power is 6. So for 6 we can remember, till 6 we can remember, and then we are going to simply use this binomial expansion. A minus x to the power 6 as the coefficient 1 and a to the power 6 minus x to the power 0. 6 coefficient, a to the power now reduced 1 and then minus x to the power 1. Similarly a power 1 again reduced and minus x power increased. Similarly we can go on, but since they have asked the first 4 terms, so we have only chosen this till 20, the 4th term. So if you simplify, it is a to the power 6 only, minus x to the power 0 is 1, and 6 into a to the power 5 is that as it is, minus x to the power 1 become minus 6 a to the power 5. Similarly here it is 15 a to the power 4 x square, and here minus x cube means it will give minus. So we got minus 20 a cube x cube and so on. So we have this first 4 terms of the expansion in the ascending power of x. And here the b part, given that the coefficient of x square in the expansion of a1 plus 2 over ax into a minus x to the power 6 is minus 20. This is given. This is another type of question which comes in the binomial expansion. Find in exact form the possible value of the constant a, and we can take the take first part as a hint because they have asked us to write only first 4 terms, so we only are going to require the first 4 terms of the second expansion, it is a minus x to the power 6. So here we have 1 plus 2 over ax, and the second bracket we have expanded with the help of the first part. Now we only require the 4 terms, so we have written here and we require, they have asked us to they have given the coefficient of x square, so we are going to find x square terms here. And we can see if we multiply 1 by 15a power 4 x square, then we'll get x square term. So this is the first term. And if we multiply 2 by ax into the power minus 20 a cube x cube, then x cube and x will be cancelled and we'll be left with x square. So that's why we have only multiplied these two. I will use another color. Yeah, so we have these two terms only, which will give us square terms, x square terms. So it is 15 a power 4 x square minus 40 a square x square. And so the coefficient which is given as minus 20, from here we got this. So we got a biquadratic equation in a that is 15 a power 4 minus 40 a square plus 20 equals 0. And we can factorize it. And first of all, let's divide by 5. We got 3 a power 4 minus 8 a square plus 4 equals 0, because 8 into 5 is 40, 5 into 3 is 15, and 5 into 4 is 20. And if we split the middle term, so minus 8, 3 into 4 is 12, and 6 into 2 is also 12. So it is 3 a power 4 minus 6 a square minus 2 a square plus 4. So by first two terms we can take 3 a square common, and we got a square minus 2. Minus 2 common from the last two terms, we got a square minus 2 equals 0. And then we can write as a factors. And then we got a square as 2 or 3a square as 2, which is of course a square is 2 by 3. And afterward we solve for a, and it is a is root plus minus root 2 and plus minus root 2 by 3. And we see the question, this is given the possible values of the constant a. So that's why we have so many values. Otherwise we could have checked which value would be satisfying this. So here we can see this all values can be possible. So that's it for this video. We will discuss the last few questions in the next video. Till then, thank you so much.